For having me. Today I'm talking about an experience report of porting a fat desktop application based on Eclipse technology to something that can be executed in the cloud. So the agenda of this talk will be to talk about our goal that we were following when working on this project. I will also give you some context of the company I'm working for so that you get an idea of what we actually do, but I will keep this very short so that it's not boring. After this, I will talk about the actual experience that we made. So I will show you which components could be reused and what challenges there were. And after this, in the final step, we will talk about the future steps in the near and in the far future. And if there's time remaining, of course, we can talk about like questions and answers. And after the talk, of course, you can always reach out to me, and I'm happy to share my experiences in this field. So the goal of this talk is it's more about the what than the actual how. So that means that I want to present a usage scenario of Eclipse technologies for creating a solution for industrial automation. And another goal of this talk is to share the experiences that we made when making a fat desktop application available in a cloud environment. So first of all, the company I'm working for, Logicals, has been founded 30 years ago. From the very beginning on, we created graphical editors to create automation programs. And Logic 3, which is the first desktop application we will be talking about soon, is the third generation of engineering tool for creating industrial automation applications. There are two offices of Logicals. One is in Austria, close to Vienna, and one is in Germany. And in total, we have around 35 employees. So Logic 3, the product that we want to make available in cloud environments, is an Eclipse-based project, and it's an IDE to create logic for programmable logic controllers, so-called PLCs, according to the IEC 61131-3 standard. So this standard includes languages which are both graphical as well as textual. The textual languages, structured text basically, and almost all other languages are graphical. Most prominent in this case is a function block diagram, which you can also see in the screenshot here. So the ultimate goal of using Logic 3 is to create programs that can be executed on so-called PLCs, Programmable Logic Controllers, and we distinguish between two different types. One is based on microprocessors, which is the one you can see on the right, and microcontrollers, which you can see on the left. And Logic 3 will create the logic that is then executed on these PLCs. The PLC that we create programs for is also a product of Logicals. So we could say that Logicals has two core products. One is the IDE to create the programs, and the other one is the runtime, or the PLC, soft PLC, that then executes the programs that have been created in the Eclipse-based IDE. Our programs are being used in different fields of automation, so automotive, so in 80% of all buses in Europe use the runtime system from Logicals to at least do, I would say, the comfort stuff, such as opening, closing doors, and other functionality. We're also into building automation, so cruise ships, for example, into the energy sector, basically into hydropower, then into agricultural machines and systems. By systems, we mean like factories or plants that are quite complex, so for example, a steel mill. And as you might guess, the range of the complexity of the programs that are being developed using Logic 3 is quite huge. So like for the automotive area, the programs are quite small, and like from the complexity point of view, they're not too big. But on the system field, we are facing programs with multi-million variable instances that have to be dealt with. So I will now give you a brief intro into Logical 3 so that you can understand what it actually looks like. So, as mentioned, it's a typical Eclipse-based product. So on the left-hand side, you can see the project structure, and on the right-hand side, in the upper right-hand side, you can see the editor. In this case, I'm displaying an ST fragment, structured text, and on the lower end, you can see the problems and error log view. So to give you a brief intro to PLC programming, in case you're new to it, so this program consists of two parts actually. The first one is the variable declaration or section, and the other part here is what's the actual logic of the program. And if you know the Arduino framework, for example, it can be compared, what you can see here, it can be compared to the loop function. So what's currently selected in blue is executed in a cyclic fashion over and over again. And you can, or the user can also determine in the parameterized section the frequency in which the program is executed, for example. So now that the program has been created, it's very simple, but I think you get the idea. The user can change into the application testing perspective, which is organized a little bit different. So on the left-hand side, one can see the so-called instance view, which gives you a logic representation of what has been programmed in the editing perspective. And here I prepared, or here you can see the prepared program. And I will now move these variables being used in the program to the values of variables view. I think it is quite small, but there is another option to look at this. We can also open a special variant of the editor for the structured text, which has placeholders for the values of the variables. So as soon as I connect to the PLC, I'm sorry, when preparing this, I forgot the step, just forgive me. So once more. So I just restarted the PLC, the soft PLC, which can also be executed on Linux or Windows. It's quite portable. Let's now again try to connect to the controller. It should now be possible, or not. I'm sorry for the show effect. Okay, just one more moment. I will now look into the configuration. So here, for example, one can find the frequency with which the program is being executed. And among these parameters, one can also find the communication parameters. So it should actually connect to the PLC running here on the system. So I will try to restart it once again. And now, hopefully, everything works as expected. Okay, so I think I have to live with the show effect. Now, what should have been possible is to connect to the logical controller, and we should have been able to see the values of the variables changing over time. So, but I think for this talk, it's good enough to understand that we have like a typical Eclipse product that should now be used in the cloud. So what will we do is next? I will talk about the actual architecture of Logical 3. So Logical 3 consists of the editors for the languages, structured text and function block diagram. And aside of that, there's also the binary build infrastructure, which is used to compile what's being edited before. So between the SD and FBD editor and the binary build infrastructure, the program that the user created is transformed into C code, into portable C code, and in the binary build infrastructure, this portable C code is then compiled and linked for the target platform, and as a result of that, the target communication part of Logica 3 then transfers the resulting binary using the target communication framework, which is yet another Eclipse project, to the runtime system. And the runtime system consists of several plugins, such as a communication plugin, which is used to communicate with the engineering system, and also a scheduler, which is then in charge of executing the PLC logic. So the binary code that has been created using Logica 3 is transferred to the target system and loaded on a Linux system, for example. It is being loaded as a shared object to the application. And then it is executed according to the parameters that have been set in the PLC configuration. Try to keep in mind these three parts on the left, because these three parts already give us an idea of what the architecture in the cloud might look like. So this is a very, very, very high-level view of the architecture of Logica 3 being usable in a cloud. So on the right-hand side, you can see web browsers, which are the typical front-end for the PLC developers in the future. And they run the Theia front-end. And the Theia front-ends are connected to the Theia backend, which is already running somewhere in the cloud. And behind the Theia backend, we will use as much as possible of Logica 3 to enable users to do their PLC programming job, right? And these three Logica 3 instances that you can see here already correspond to the three components that Logica 3 is basically made up of. So the Logica 3 server in the middle is responsible for all the language features, like language server protocol and all the code completion tasks and all that related to the language. The build server is in charge of compiling and linking the generated C code to what's needed for the platform. And the target communication server, in turn, is in charge of transferring the program to the actual PLCs, which are then like on the target side, running somewhere. So let's now have a look into Logic Cloud. So Logic Cloud is, the interface is, I think, quite familiar to you. So on the left-hand side, again, we have the project area. On the right-hand side, there's the editing area. And it is actually showing the same program that we've seen before, but it still contains some comments. Again, what's possible here, as Logic Cloud is already aware of the language because of all the backend and language server stuff, it is possible to use features such as rename a variable, for example. Here the variable name count is being renamed to C and T, for example, and all this then works out of the box because of the language server protocol running in the background. Something else we can see here is the instance view we've seen before. So this is the view that is being used to communicate with the target. So what you can do here is you can, for example, instruct Logica 3 or Logic Cloud in this case to create the binary code, or you can instruct it to load the binary code that has been generated to the target. So now let's talk about what's going on behind the scenes. So this is, again, a very high-level view of Logica 3. It's a bit more in detail than we've seen before with the three components. The question is now, how much of Logica has been reused to implement what we have now for Logic Cloud? And the answer is almost all of it. So all the language parts could be reused, all the build infrastructure could be used, and the target communication could be reused, and the parts that could not be reused to like, let's say 100% were the editors, which contain Eclipse UI stuff, which is not available in the cloud, and also the instance view, which is, as mentioned, used to communicate with the target and to trigger the binary code generation. These views, at least, the graphical components, had to be redeveloped. So when coming back to the implementation or to the Logic Cloud prototype that we have, this is what you can see on the left-hand side on the screen. This had to be reprogrammed. So it's still behind the UI, it still uses like the logical interfaces, but the front end had to be redeveloped because it could not be reused one by one in the cloud area. So why is it possible that so many components could have been could be reused? So Logic 3 is actually a product it's not the final product. Logic 3 is a product that's usually branded by OEMs, and they distribute and they sell the product under their name. So what we made is we created a public API for Logic 3 that allows OEMs to extend the IDE by almost any functionality they want to implement. And they can, using this API, they can also use almost all functionality that's available in the menus or somewhere else in the IDE using an API. So as a result, it is quite easy to extend Logic 3 itself, but more importantly for Logic Cloud, it is also possible to create standalone applications, right? So this abilities and this background led to the architecture that we have in place right now. So on the right-hand side, you can see what's running in the browser. This is basically the Theia frontend, and on the server side, we have the Theia backend and the Logic servers, 3 of them, corresponding to the 3 components that we had in the previous slides. And in the front end, there is also like proxies, let's say, for the components or for the services offered by the backend. And so the Theia backend is actually more or less, again, a proxy for the Logic servers running in the background. The connections between the browser and the server are all TCP-based, and at the moment it's implemented in that way that on the server side there's only one TCP port. There's only one TCP port that needs to be open on the server side. So it's all going into a single point into the server, and the server, the Theia backend, is then responsible for forwarding all the requests and all the data that's needed to the actual backend, implemented as Eclipse-based server components. So the protocols being used between the browser and the server is like plain HTTP GET and WebSockets based. So for the service, for everything that's not language related, it's gRPC over WebSockets. It's RPC JSON over WebSockets, right? So let's talk about the key enablers for this architecture, Logic Cloud. So there's one missing here, which is the TCF, the Target Communication Framework, which is being used to communicate between the target communication Logic server and the actual target. But more related to the cloud area are Xtext and LSP for J, which work together quite well. So Xtext is able to generate what's needed to offer the language server protocol as well. Then, of course, Eclipse Theia. This is what you could see in the web browser and what's running in the background. Then Eclipse GLSP, which is used to do this language stuff for graphical components. And today there's another talk about it at 3 o'clock and 10 minutes, if you're interested in that. And the future, not being used right now, Eclipse J, I think, will play an important role to do the workspace management and to work together with the underlying infrastructure for Logic Cloud. So let's now talk about the challenges. So I've mentioned that Logic 3 is being divided into 3 standalone applications running in the backend. And in order for the applications to be as self-contained as possible, it is also important that the dependencies are managed in the right way. So we divided we categorized the dependencies into 4 categories. One is UI dependencies. These are the worst dependencies. So in case there's functionality that should be available in the cloud depending on an UI feature of the Eclipse framework, it's really bad because there's nothing like this in the cloud or Theia available. So you really have to make sure that the code that should be run in one of the backend services doesn't use it at all. So that's actually the reason why only part of the custom editors can be reused in Logic Cloud from Logic 3. Then Eclipse dependencies can be discussed. So Eclipse dependencies typically refer to the builders or the workspace. And when it comes to the workspace, there's another challenge I will talk separately about in one of the next slides. We decided to stick with the workspace dependencies here and there. We will, as mentioned, talk about this soon. And the lower 2 categories, OSGI and let's say the OK dependencies, stay as they are. So OSGI dependencies refer to like all these service access because as you almost all know, I think that Eclipse is made of plugins, and in order to play well with the plugins, OSGI is needed. And the OK dependencies refer to components that only depend on Java environment to be executable. So what we did here in order to get the dependencies right was to use software to help us with that. So we used the class Dependency Analyzer, which is capable of determining dependencies on a class level, on a package level, and on the plugin level. It does not only visualize the dependencies, it's also capable of generating CSV files that can be used to get a very nice view of what needs to be done. So basically, we created a spreadsheet that showed us where is work needed to get the dependencies right the most, right? So green is it's okay, and the darker the yellow or reddish is, the more work needs to be done here. So the next step was to think about the workspace. So some of Logic 3 functionality depends on the Eclipse workspace. So typical classes in this field are the iProject interface, I think. And functionality that depends on this should be handled especially because Theia IDE does not know the concept of Eclipse workspaces. Right, so this, for us, the solution was to create a cloud-aware workspace implementation, which does not depend on any Eclipse workspace dependencies. And of course, it behaves a bit different than the Eclipse file system, iPath interface, for example. And of course, this limits the possibility of shared code with Logic 3. So when we come back to the very high-level architecture of Logic Cloud, one can see that Theia backend does not work with it. So it has a more or less file system-based implementation of the workspace, and it's, as you know, implemented in TypeScript. And as the Theia backend does not know the concept of Eclipse workspaces, the components it talks to must not use the Eclipse workspace as well. So what we did is we made the Logic 3 server, which is responsible for all the language stuff, not using Eclipse workspace anymore. So this component is also using the cloud-aware workspace, which has been re-implemented. And the only component that still uses the Eclipse workspace now is the Logic 3 build server, which is compiling and linking the code to the target platform. So what happens in case the user says, let's generate the application? The Theia backend and the Logic server generate an Eclipse workspace, meaning the .project file and all other files that are needed in the workspace, and it's transferred to the build server, and the build server is then instructed to build what you got, right? The target communication server, which talks to the actual target, does not need any workspace at all. So what do we want to do in the near future? In the near future, we also want to build in the support for C and C++ editing, because it should be quite easy, because of almost all components that are needed to achieve this goal are already available, such as the language server for C and C++ is based on the LLVM framework, meaning Clang. And we also don't have the diagnostic features, which allow the PLC programmer to investigate on what's running on the hardware, right? So you, as a PLC programmer, you can typically observe the values of the variables changing over time, and this is not supported yet. We also want to continue the FBD support, to work on the FBD support in Logic Cloud. I can give you a brief overview of what's working right now. When we look into this here, this is a FBD function block diagram program that has been created in Logic Cloud, and this is also, of course, this is also possible in Logic 3. I will give you a comparison of this right now. If we look into this is the same in Logic 3. So this is yes, available in Logic 3, and in Logic Cloud, what you can see here is already transferred and handled through the GLSP protocol, right? So that means that almost all functionality in the available in the FBD editor, such as content assist to add new blocks. Let's say I want to add something bigger, some element here. This can also be done the same way in Logic Cloud. So you can see that the content assist is already available. This is done using all the available language infrastructure. And then, hopefully, okay. So there are only a couple of blocks available at the moment, but still, it's all based on the language infrastructure of Logic Code, based on GLSP. So we want to continue to port all the use cases of Logic 3 to Logic Cloud to find out how well we cope with the architecture. Then the far future, there are also other challenges that need to be faced. So as Logic 3 is a solution that's being integrated by vendors, by OEMs, they typically also integrate what they have as a compiler. So in case you're using commercial compilers, you have to consider that they have special licensing terms regarding being usable in the cloud. So most of them already consider this, and as they are considering it, and we also have to consider this. Then again, the workspace management is just, it's not a workaround, but it's just a temporary solution. We have to work on this as well. And we also have to think about using this in an Eclipse-J environment. And as an implication of that, we also currently thinking of where to run Logic Cloud actually, because we don't want to host the infrastructure ourselves, because it is it's not doable because of the resources that we have, and so we are currently in the research phase for where we could use where we could run Logic Cloud actually in the end. Another thing is that Logic 3, as mentioned, is a solution that's typically branded before it's being used by end users, and Logic Cloud should be developed according to the same aspects, right? So that means that Logic Cloud should also be offered as a solution that can be branded and adapted to the OEM's needs. So we actually don't want to host it, but we also don't want to offer a service for PLC programmers ourselves, but we want to enable our customers that they can do this. So as a summary or as a finding, I would really recommend you, in case you're thinking of going towards the cloud, build proof of concept prototypes. I think this has also been mentioned by people from EclipseSource yesterday, and I totally agree. So first of all, define the use cases that you want to work on, make sure they're really well defined, and after this, just start working with it, and with a simple use case to get to know the technologies and the frameworks. And when implementing the first simple use cases, you will also get a rough understanding of the time that's needed to get your cloud solution ready. So further reading, what can I recommend you to get started with, in case you're at that step? There is an initial Eclipse Theia design document. It has quite an age. I think it's 2 or 3 years old, but still it gives a very brief idea of how things are thought to be, or their high-level architecture at least. Then I can really recommend the blog of EclipseSource, because they have quite some articles which explain the concepts of Eclipse Theia. So, for example, the distinction between Theia extensions and Theia plugins, and the terminology in overall. And as a motivational example, I really recommend you to look into the documentation of the Theia IDE, because as soon as you have a command line on a Linux or Windows system available, I think it takes maybe 15 or 30 minutes, and you will have your first Theia IDE running in the web browser. It's really quick, really easy, and it's really motivational to see that you have an editor running in the web browser, even with Git support, for example. Yes, so this brings me to the end of my talk. So if you have any questions, I'd be happy to answer them. Yes?
So how much of the graphical editing do you have to rework? Or could you reuse like some technology for that?
So I would say when developing Logic 3, we made sure that the actual UI components are well separated or isolated from the actual UI logic, right? And this helped us quite a lot to keep the time very low. Maybe I would ask Philipp Lange, who was involved in this quite more than I was. Maybe he can give you a more detailed answer on this. Yes?
I was wondering when regarding the X-text mode and the service we have this very similar product, and we have like noticed that, for example, we had a lot of application of content assist, and so do you have any problems, for example, in the X-text mode or in any places where you had to rework a lot of regarding not regarding the editor, for example, in X-text, the content assist.
Okay. Okay. The question was how much work was needed to get X-text comfort features, such as the content assist, up and running again, with like what was there in an Eclipse-based product and then in the cloud. Yes. So I would forward this question to Philipp, to be honest.
Yes, right. I would say 90% of just work out of the box. There are a few things that are maybe different, like not really indenting and not doing auto completion and stuff like that. There's minor fixes involved. That's the only issue the new one that we see. And last but not least, of course, you have to redo the highlighting and snippets, because that's client side only.
So 90% could be reused is the summary. Any more questions? Okay, So thank you. So in case you have any more questions at any time, just reach out to me. You will find me here in the conference area.